Hello everyone, welcome to the course on Foundation and Substructure Construction. I am Xu, the lecturer of this section. Today, let's learn about the earthwork backfilling. This section focuses on explaining earthwork backfilling from the aspects of earthwork backfilling, soil material requirements, and water content control, substrate treatment, earthwork slope, manual filling methods, and machine filling methods. Next, let's start today's lesson together. First, let's look at the first part, soil material requirements and water content control. The requirements of the soil material should comply with the design requirements to ensure the strength and stability of the field. If there are no requirements in the design, it should comply with the following provisions: 1. Gravel, soil, and sand, and blasting gravel. The particle size shall not be greater than 2/3 of the thickness of the soil laid per layer, which can be used as filler under the surface layer. Guts, cohesive soil, whose water content meets compaction requirements, can be used as filler in the process. Silt and silty soil generally cannot be used as fillers, but if the water content of softer soil refined treatment meets the compaction requirements, it can be used as a secondary part of filling. The water content of fill soil directly affects the quality of compaction and compression. Before compaction and compression, tests should be carried out to obtain the optimal water content and the minimum number of compaction that meets the compaction requirements. If the water content is too low, there will be insufficient compaction and compression. If the water content is too high, it is easy to form rubber soil. The reference values of optimal water content and maximum compactness of various soils are shown in the table below. The difference between the construction water content and the optimal water content of cohesive soil can be controlled in the range of -4% to +2%, and in the range of -6% to +2% when using vibration compression. The simple method of detecting the water content of soil on the construction site is generally the property of forming a lump when held in hand and smashing into pieces when falling to ground. When the water content is too high, it should be loosened and air-dried, replaced with soil and backfilled with dry soil or other water-absorbing materials, etc. The optimal water content and the maximum compactness of other types of soils are shown in the table below. The second part is substrate treatment. Substrate treatment includes 1. For site backfilling, the garbage, turf, and tree roots on the substrate should be removed first. Water, silt, and debris in the pits should be removed, and measures should be taken to prevent surface water from flowing into the filling area and soaking the foundation, causing the foundation soil to sink. 2. When the filling substrate is planting soil or losing soil, the substrate should be fully compacted and compressed densely. 3. When the filling soil is located in loose soil sections with high water content, such as paddy fields, ditches, ponds, etc., drainage should be taken according to the specific situation, or excavate all the silt to replace them with other soil, or to take other measures such as filling with gravel and sand loosening and mixing line. 4. When the ground of the filling site is steeper than 1 to 5, the slope should be dug into a step shape. Each step should be 0.2 to 0.3 meters, and the step width should be greater than 1 meter. And then the soil should be filled in layers to facilitate joining and prevent sliding. Thirdly, the slope angle of earthwork slope fill should be specified in the design according to the fill height and the type and the importance of soil. When there is no specification in the design, please refer to the table. As shown in the table, the angle of temporary fill slope that has been used for a long time can be made to 1 to 1.5. When the fill height is less than 10 meters. When it exceeds 10 meters, it can be made into a polyline slope with the upper part adopting 1 to 1.5 and the lower part adopting 1 to 1.75. Fourth, the filling methods. The filling methods include manual filling and mechanical filling. The manual filling method uses trolleys to carry soil and manually backfills with tools such as shovels, scrapers, hoes, etc. Filling should begin at the lowest point of the site, from one end to the other end. Start filling from the bottom to the top. The thickness of loose laying of each layer not more than 20 centimeters. When compacted with manual wooden rammers, and not more than 25 centimeters when compacted with mechanical rammers. When the deep and shallow excavation are connected, the deep part should be filled first. After the two parts are leveled, the entire area of both pits should be entirely filled in layers. If we adopt sectional filling, the junction should be filled in a stepped shape. When filling soil manually, we generally use 60 to 80 kilograms wooden tampers, iron tamper, and stone tampers. 4 to 8 people pull ropes and 2 people support the tamper. The lifting height is not less than 0.5 meters. One tamper overlaps half of the previous one, and it is carried out in sequence. When manually backfilling a large area, we use mechanical rammer for compaction. The distance between the two parallel substrates shall not be less than 3 meters, and the distance between the front and back on the same compaction line shall not be less than 10 meters. Fifth, mechanical filling method. Mechanical filling methods include bulldozer filling, scraper filling, and automobile filling. Bulldozer filling should be paved in layers from bottom to top, and the thickness of each layer should not be greater than 30 centimeters. Large slope filling should not be condensing or pushed at one time without laying. Bulldozer earth moving and backfilling can adopt the method of dividing piles and pushing and filling them at one time, with a segment distance of 10 to 15 meters to reduce the amount of earth moving leakage. When the earthwork is pushed to the filling part, a blade should be lifted once to unload the earth in piles and push forward 0.5 meters to 1 meter and use bulldozer to retreat and level the earth. When a bulldozer is driven back and forth for compression, half the width of the track should be overlapped. The filling procedure is to adopt the longitudinal paving sequence from the cut section to the fill section with a distance of 40 meters to 60 meters. Scraper filling. The length of the filling section should not be less than 20 meters. and the width should not be less than 8 meters. The filling should be carried out in layers, and the thickness of each filling should not be greater than 30 to 50 centimeters. After each layer of soil is paved, the soil is leveled when the empty car returns. Generally, the filling procedure adopts horizontal or longitudinal unloading in layers, as far as possible to facilitate the initial compaction. During driving, dump trucks unload soil in pairs, so they need cooperation of bulldozer to push and pave the soil. The thickness of each paving soil should not be greater than 30 to 50 centimeters. Part of the compaction work can be completed by car driving. The driving route must be evenly distributed on the fair layer. Cars cannot drive in losing soil. Unloading, pushing, and compaction work must be carried out in sections and crosses. Alright, today's lesson ends here. Thank you.